Okay, we are recording. Thank you for your assistance. Okay. Hopefully everybody knows who Steve Jobs is. Okay, good. All righty. And moving along, we're talking about how vulnerabilities get into software. Several of these slides are from Dr. Yuan, and some of them I made myself. A couple announcements. We are now on Unit 11 in Blackboard, and next week is Unit 12. As you might know, we kind of jumped around. We went 9, 10, 13, 11, 12. And I didn't renumber anything just to keep it confusing. So I just moved 13 ahead because the topics seemed like 11 and 12 should go at the end because they are a collection of a sort of material for secure computing. There's some reading material for Unit 11. It is out of, there's links on Blackboard under additional resources. If you get to Unit 11 and you look under additional resources, there are 2 links to PDF files. They are relatively short. One of them is 6 pages. One of them is 10 or 12 pages, but it's got lots of pictures, so, graphs. So, hey, it's easy. And a reminder, next week, November 15 and 17, it's online only. No in-class campus material. So, okay. Some people are having some issues with projects 5 and 6. Tomorrow, Tuesday, we're going to have a TA session. The TA and I will be online on Zoom, the usual course Zoom ID. And you can Zoom in and we'll try to answer questions about projects 5 and 6. The deadline for project 6 has been moved to Wednesday at midnight, so you can figure out what your problems have been or what the problems are. Apparently, there may be some environment problems with project 6, so we'll hopefully resolve those and understand them tomorrow, and then you can work on it and get it done by Wednesday. So no problem there. I will record the session, at least I'm going to try to remember. If people remind me to record, and then we will be able to put it out on Blackboard or YouTube or someplace so you can see it if you don't have the opportunity to attend at that time. And today we're going to talk about secure software development, part of the how do problems get into the software, how do vulnerabilities get into the software. On Wednesday, we will review encryption. I assume by now, most of you know all about encryption, and I've probably heard about it in several other graduate courses. But I'm going to review it once again, just to make sure it's kind of an important topic, to make sure that everybody understands it. And it's used a lot. So encryption review on Wednesday. And then next week, common security flaws. Again, there was a move back near the end because it's a hodgepodge of several problems that exist in security. Okay. Now, the title, as Dr. Yuan said, it was how do vulnerabilities get into all software? Well, you put them in. It's all about you. You are the cause as a programmer. If you write insecure code, you leave your users vulnerable to attack. But positively, you are the solution. If you write secure code, if you pay attention to what we've talked about this semester, and you avoid the vulnerabilities, then it's much more likely that your users will avoid the attacks. In other words, given, of course, it's the if you have multiple websites out there and you've taken a lot of effort to prevent attacks and other people haven't, then they're probably the ones who are going to get attacked. You don't have to run faster than the bear, you have to run faster than the other guy. Okay, so what are the problems? Basically, security is a software problem. It's a software reliability problem. People write code that has flaws in it. Sometimes they're just basic bugs or errors in the code that doesn't work well, and an attacker can take advantage of that. Other times, they overlooked a potential problem. We've seen all sorts of problems, and developer may be unaware of these problems and may fail to take precautions to prevent them. And of course, it's all about understanding the risks. What are the problems and what do you do to avoid them? Now, good software security says we ought to think about it in the whole lifespan of software development. You want to start early. You want to start by in the very beginning, when you start planning your stuff, think about security. Don't wait to the end. And all along, there are things you can do throughout the software lifespan. And this has been shown through many studies. On the other hand, and this is one of the studies from IBM, here is the relative cost of fixing a defect. So you find a problem. And this is, by the way, for defects in general, not just security flaws, but just general program bugs, if you will, that if you say, well, you can look at it, if you find a mistake during the design phase, you can fix that, the cost of one. Well, if you wait until the end, maintenance, if you already released the product and you have to then fix it, there's a cost of 100. It's 100 times more expensive to fix the product once it's been released. And Microsoft and several others have documented this, that it costs a lot of money to send out a fix. Also, it doesn't make your customers very happy when things don't work. And you can see that if implementation, yeah, it's 6.5 times more difficult to fix than design, and twice that or more to fix it during testing, if you find it during testing. So basically, the earlier you find it, the earlier, the easier it is, the less expensive it is to fix it. Now, even though this has been documented for some time, people have known this. Hey, I've been in this business for a long time. People have known this for decades. Nevertheless, that's not really what happens. I read this Osterman research report. It's one of the reading out on Blackboard. And okay, so they asked people, professional developers and security teams, when should they start working on the security? Where should security be considered? In the SDLC is software development lifecycle. Well, you'll see that a little bit less than a third of them, particularly the developers, thought it'd be done in analysis requirements. Some of them planning. It picks up a bit in development, testing, and maintenance. Only about 1% of them thought it should be done in maintenance. So people are pretty much, and yes, it does move the planning to the left. And in some of the documents, they talked about shifting to the left. What was the difficulty in shifting left, meaning getting the people to consider security problems earlier? And you'll see that the security teams thought it was more important to do it early. What developers themselves weren't as on board as that. So this is contrary to what people know to be the cost. We'll talk about why. But the problem is getting bigger. Why is the security problem getting, well, because there's more people using the web and they're wider connected. Used to be, those of us with gray beards remember the days when computers were kept behind locked doors and you had to get past the security on the door and the person standing inside in order to get to the computer. You had to put your card in the door. I had to put my card in the door, type in my code, and walk in past the operator who recognized me and let me in. And then I could use the machine in there. So it was pretty safe. No networks. Yeah, it was kind of hard to do something against a computer. And in general, most of the people didn't cause problems because they were the ones who had to fix it. But now everything's online. Everything's on the web. It's available to the world. And that does provide a much broader attack surface, and therefore more people can attack it. Also, we've become more extensible. A lot of people generate code with a lot of parts from other places. And that's good and bad. First of all, it makes it easier to generate code. I mean, you should use existing material. But if a flaw exists in that material that you didn't create, you may not know it, you could do to avoid it. But if it becomes known, then you have a flaw in your program that people know that you didn't generate, and then you have to go out and fix it because of their flaw. Okay, we've got clicker questions. I didn't bring more pieces of paper. So if you brought your paper, and I regret I didn't get them out on the web. I'm sorry they're online people, but if you will use the chat, let's see if you can figure out what the answer is here. Okay. Think about it for a minute. So I get application going. Okay. Hopefully you know the answer. Okay. And again, I forgot to bring, it was on my to-do list for today to print more of these and I forgot. So if you have one, put it up and let's see what you think the answer is. Got you. There's a resolution issue. Okay, that should do it. Oh. The three of you think you voted C? Okay, got a couple C's. All right, we've got back here online. Let me just check the online people. The online people, I've got an A. Oh, who is that? An A, and a C, I think. Okay, A, and C. All right. Well, and we have 3 C's, 2 A's, so 4. Oh, okay, we have 4 A's, 4 C's, and one person says D. Well, D, you're wrong. We're just going to go for wrong on D. The answer I was looking for was the A. The best time, at least if you remember, yes, if you do the design and you find problems, then it's really easy to fix. Not that everybody wants to do that, but that's always the testing. It is relatively, a lot of people do testing. We'll talk about effectiveness in a minute, but ideally you do it during the design. Think about the security then, because it's easiest to fix problems. Okay. Any questions about that? At least that was I was thinking the answer. Did you have a reason why testing was so wonderful? Anybody? Okay, well, yes. A lot of problems are fixed in testing. Okay. Another issue, again, following the why do we have problems? Why are the problems getting worse? It's because programs are getting more complex. They're getting bigger and more complex. More lines of code, more opportunities to make a mistake. And then we have fixes and fixes overlapping other fixes. And it just causes a lot of opportunity for things to go wrong. Dr. Yuan defined defects, bugs, and flaws as 3 separate categories of errors. And I went out and Googled this and found out that there are a whole bunch of different ways to cut the problem up. Defects, bugs, and flaws is one, and there are other ways to do it. But basically, there are some problems that are built right in. You designed a mistake, and it's a defect. It doesn't work the way you want. Also, it may be that you didn't design it the way the customer wanted it. That's a defect. Bugs are implementation level errors. In other words, we got the design looks good. The coder miscoded something. They made a mistake, and that mistake is a security flaw. And so, those are relatively easy to fix because they can, once you find them, well, okay, it's debugging. You probably debugged a program or 2 in your life, and that's, again, it's easier to fix it at that level than it is to fix it later. And defects, once you find a defect, though, it's more difficult to fix later on. And the flaw, again, the flaw is more subtle. Oops, sorry. Flaw, again, part of the design level. Well, sometimes you don't even know it's there. Sometimes the flaw may have been there for quite some time and you didn't know it. Well, all the bugs, such as buffer overflow, you know, never happened. Nobody noticed it until one day somebody noticed, oh, you're vulnerable. And then they made use of that. You never knew that problem was there, but you got it now. Okay. These things, problems in your code lead to risks, security risks. And it all depends on the probability of these things. So how bad is the problem? What is the impact? If you have this problem, what kind of problem does it occur? Is it a minor issue? Is it a major security flaw? Is this going to really mess you up? And what's the probability that it occurs? So you have the likelihood that the bug occurs or the problem will occur. Not, the bug is there. What's the likelihood that it will happen? And what's the probability of its impact? So you have to you have to manage that with risk. You have to consider the how likely the problem is and how much impact it's going to have. And also, what does it take to fix it? How much effort is it going to take to fix the bug? And then errors have a big range. They can come from everywhere. They can be implementation problems in that user used, in this case, they're talking about insecure methods like getS. getS is a C language or C++ language, a method that reads a string from the console. It reads it into a buffer. Thing is, it doesn't know the size the buffer is reading into, and it reads all the characters you give it and puts it in the buffer and any other bytes behind after it until it runs out of, until the input is done. It doesn't care if it runs off the edge of the buffer. It doesn't cause an error. It just, well, it doesn't cause an immediate error. It doesn't cause a detected error, but it may cause some real problems later. Well, I'm probably not going to do an assignment like that, but I have done assignments like that where you intentionally cause a buffer overflow, and you can change, particularly if it's a stack overflow, you can change the user's stack, cause the program to execute code that you never imagined. The mid-range level is that, those are things that cause it maybe to hang. It's about race conditions may usually cause your program to hang or not work some of the times. So some problems are hard to find, and there's automated tools to find these things. Now, application security, yes. I had to read this a couple of times before I knew what Dr. Yuan meant. But application security is basically fixing the security problems as opposed to designing security into the code. Application security is the idea of looking at an existing application and trying to make it more secure. Whereas the better way is to build it secure to start with. As we talked about earlier, doing it in the design so much easier than doing it at the maintenance level or the testing level. Most corporations look at security as an operations issue. That is, okay, you got security, we're going to rely on the technicians in the network, on the firewall to make sure they got all the antivirus stuff out there, to do that to fix it. It would be much easier, of course, if the software, they should do that. Yes, they should do all those things, but it's much better if the software itself didn't have all the errors in it and wasn't so vulnerable. Basically, it's much easier to defend code that works well. There are certain textbooks that define 3 pillars of software security. One of them is applied risk management, software security touch points, and knowledge. So we'll go over those 3 right now. Applied risk, okay. A lot of the business people talk about risk and managing risk. It can be a business level decision based on what is the cost of a problem and what is the risk of it. Should you ignore it or not? And again, it's a means of going through the software development life cycle, looking for risks at different layers. So risk management often plays around probabilities a lot as well. What is the likelihood that this error will occur? What is the cost of that error? What kind of damage will it do? And so you can look at a chart here. Those things that are likely to occur, easy to fix, those are the ones you want to fix first. And it likely, and I didn't even do the estimated cost here. Actually, there should be 3 dimensions. Likely, ease in fixing, and cost of errors. Check. I didn't quite do that right. But you can see that the things that are really broken, that are likely to occur, those are the things you have to fix first because they're likely to occur. Then there's the ones that are likely but difficult to fix. Because they're very likely, you better take care of them soon. And then you get back to those things that are not so likely, but you can fix them without too much effort. And then, of course, the last things you worry about are the unlikely ones that are difficult to fix. And those are the ones that may not get fixed for a long time. Okay. Software security touch points. There are a couple different, many different ways to do software development. Touch points is one of them. And again, it's talking about software security, that it's not security software. You build your security in. You take, as you design it, you think about all the flaws that you know, all the dangers that you know, make sure that you don't do things that make it vulnerable to those dangers. We talked about most of this. There are a bunch of different software development processes. I'm just going to mention 2 of them here. These are security development processes, and these can be added on to regular software development processes. You can do whatever software development process you like. If you're agile or waterfall or whatever you like, you can add these on. So we have one of them is the Microsoft SDL, Software Development Lifecycle. That came about in 2004. There was a memo. I think I'll talk about that when I get to this. Yes, Microsoft came up with it. They've mandated it now. Then there's software security touch points, which was developed by Gary McGraw back in 2004, about the same time. And that's been adopted by several US agencies. There are many others. And you can see things are better now than they used to be. Yes, because we had in the past it's miserably secure software, and all the threats that we've talked about in this class were all known. Most of them were all known way back then. People were not protecting themselves. SQL injection. Well, that's been a problem for a long time. But by now, most developers know it's a problem, know how to avoid it. Back then, they weren't paying attention to it. So a lot more software was very vulnerable. And so it was much more of a problem. Okay, so we got another clicker question here. So which defect should you fix first? Let's take a look at that. Okay, that's an easy one. Online people can click. Okay, let's do that. All right, let's see some numbers. Okay, you're looking at it. I gotta look at it. Oh, okay, gotcha. Yours, that's it. Okay. got you. All right, then. Okay, I've got 4 C's to cover on and the online people. The online people, or A's, or everybody's in the A's. Everybody wants it. Okay, so we have 5 A's, 4 C's. So it's a tie. Well, almost a tie. A's and C's. Okay, I would go for definitely A over C. A has a higher danger and it's easier to repair. That everybody good with that? I mean, B isn't much of a danger, even though it's easy to repair. D again is not much of a danger. It's the same effort to repair as A, but A has got much greater danger. And C has moderate amount of danger, not as much as A, but it's harder to repair than A. So A would be the answer. Okay. Moving on then. Okay. Okay, software security touch points, again, are the McGraw concept of how to manage software security. We'll talk about that. And it can be applied to a variety of software development processes, you know, the waterfall, the spiral, the agile, whatever you happen to like. So you apply these concepts to your current development process. It's got this diagram here. There are, again, usual things, you know, requirement, use cases, requirements, use cases, and then architectural design. And then you get into plans for testing. Plans for testing, which is usually, you notice that's developed before the code. Then the code, then you actually test it. And then at the end, you released it and you get feedback from the field. Things are not going right. And you go back and cycle around doing this over and over again. Keeps you employed. So again, and then there are things you can do, but we'll just go down these. It turns out that, you know, you can see the software development process goes from left to right, where requirements and use cases are the very first things you do, and then you code it, you know, after you do the design system. But there's several activities you can do. The touch points that they have, those are the code ones. And let's just look at these code. Turns out the most effective one is code review. There are also tools to do that. There are a lot of tools out there that you can run that will go through the code, often static code review, that look at your program and will look for potential errors, potential security flaws, potential security hazards. Or if you're using vulnerable functions, it will flag those, and other areas where it believes perhaps something may not work. And so turns out, even though coding is, you know, getting much better, more effective to find the errors in requirements, code review is highly effective. It finds lots of errors quickly. Risk analysis is second, and it does start there in the beginning. Third is penetration testing down here near the end. So you can test it when you're done, do the pen testing. Risk-based security test and test plans. In other words, when you plan the test, what are the errors and what are the likelihood that they may occur? Put those in the plan. And of course, you should look at abuse cases and security requirements from the very beginning. And the last thing is operation security, most effective. Okay. Now that was the touch points, McGraw touch points. Microsoft has the trustworthy computing environment in which they develop their software development lifecycle plan. Back in 2002, Microsoft was getting beat up a lot because their software just wasn't very secure. Again, I mentioned around that time, there were people discovering a lot of the flaws and people hadn't fixed them. So Bill Gates wrote a famous memo, of course, Bill Gates being at that time the CEO of Microsoft, wrote a memo to all the Microsoft employees saying, stop what you're doing. Everybody at this point, everybody in the company is going to work on security now. Don't write another line of code until we have security classes, everybody's trained, and go back and let's work on fixing security flaws. And they spent a bunch of bucks, 300 million, a lot of worker days. Now, that actually is 2,000 worker days. Doesn't seem like a lot to me, but well, yeah, okay, that would be, think of an 8-hour day, that'd be 16,000 hours of work, but that's, well, anyway, I spent some bunch of effort on it, and it did help. They became more secure, which is necessary because they were getting beat up by their customers, by their stockholders, and people weren't going to use Microsoft because they can't use Microsoft because it's insecure. So we got to do something about this. So they went back and tried to fix everything, and they came up with a software development lifecycle for security, and they trained everybody in building secure products, made testing and following a series of milestones required for doing all this. They made some tools, prefix and prefast are some tools. Again, there's static analysis tools for looking for defects. You run them against the code and it flags certain lines of code because this may not be secure. Yeah, by the way, they're not 100% reliable, but it is something to look at. Also, if you change the Visual C++ compiler, the Microsoft Visual C, they changed that to help detect problems. Yes, that was what they did. Is they put what they call canaries, or software canaries, between the data values in memory. Okay, so you have a particular null value between data values. So you have an array and then another integer between them. They'd waste a word of memory and set it to a particular value. And then after you've you go to return from a method, you'll go back and check those. Are they still the way they're supposed to be? If something had damaged them, if some override flow of a buffer had changed one of them, your program will stop. It will, when it goes to the return, it checks them, and the program will halt, telling you you've damaged this and doesn't go on. Okay. They also looked at ways to measure this, because an old management thing is if you can't measure it, you can't manage it. And so they worked on how to measure the security issue. And yet another clicker question. Oh no, just clicking you again. Okay, this one's easy. How wrong can you be? Okay, online people. Okay. All right. What we got here? Come up there. Where's that pie so we can see it? Okay. Oh. Okay, I think I got it. Okay. Let's see what our online people are telling us. They're all A's again. Hey, they're getting good grades. They got all A's. That's good. Okay. We have 6 A's and 2 B's. Well, okay. It's a trick question. Of course, you want to do the earlier you start, the more cost effective it is. On the other hand, come on. If you remember this list of order of effectiveness, code review is there at the top, and yet code review is kind of in the middle. So it's not really the leftmost one. So you could say, but earlier attention to security is most cost effective. So depends what you want to say. I'll accept both answers. It's not a test question anyway. Yes. But I will warn you, some of my clicker questions do find themselves in the quizzes. Hey, I wrote the question, don't want to waste it. Okay, and then Microsoft Secure Software Development Lifecycle. And again, I think I mentioned most of this. It's a mandatory activity at Microsoft. You must follow the security thing. You have to train people. Training turned out to be very important. There's these sets, training requirements. Others are security. You have to establish security requirements. And then design, make sure that you design it with security in mind. Again, implementation, make sure you code it correctly. And then verification, you have to make sure, not only just test it, testing and code reviews and other ways to validate that, yes, it looks secure. Then finally, when you release it, you have to keep track of what the problems are, and then you have to respond to those problems out in the field. Okay, knowledge. This is the third pillar. Knowledge is just, you got to know about the problems. You have to know what the errors are, what you can do about them. And you have to train people. People have to know, or your developers have to know what the problems are, or else they're going to do it. You have to be able to find them. You have to have tools to find these things. And they have several categories. This particular author groups, principles, guidelines, rules, exploits, tech, and history. And you can go out on the web and find multiple divisions of that. But there are other multiple things one can do about it. There are patterns of software problems and solutions. Let's look at this picture. We've got, again, principles, guidelines, risk pattern, or rules, vulnerabilities. Those are the same list backing up that you see there at the bottom. 7 software security knowledge areas, and these knowledge areas impact the several touch points. Those principles attack the first 3 things. Attack patterns hit almost everything. I think it doesn't hit coding, but it hits almost everything else. Vulnerabilities looks near the end. Guidelines hit the first 3. You can see the lines. Okay. Over the last few years, there's been a significant rise in security engineering, particularly people who are hired to manage security. Of course, that that is an opportunity for you people. You can get jobs in the industry working on computer security. There are out there a lot of people who don't understand computer security, and therefore they tend to generate code that does not protect them from the known flaws. So you gotta have security people from the very beginning. I think we said that. But basic concept is that security is everybody's problem, everybody's job to fix it, not just your security engineer. You have security people in the company, and you have developers. Everybody has to be involved, management, everyone. You have to keep the operations working, and you have to keep the code developer. The managers have to know what to do about it. Also, the users have to understand what they can do to be secure. Obviously, there are things that you can do. Obviously, the unsecure thing is you have a password, you write it on a sticky note, and you stick it on the monitor. That happens a lot. You'd be amazed at how often I've gone to somebody's office, and there, on a sticky note, on their monitor, there's the password. So they have to change it every couple of weeks, and it's supposed to be random. It's really hard to remember. So you put it up there. Yes, there's a Bruce Schneider quote saying there's a oxymoron of passwords that a password to be good has to be changed rapidly and random and not written down. He says, but you can't do that because if it's changed rapidly and random, it's very hard to remember. So it's a problem. Okay, so the thing is, looking at something, that's not the way the world tends to be. The survey, again, the Austin research, which is one of the reading materials out there on Blackboard, who do they think is responsible for security? And so they have the developers at the top, the gray bars, the middle bars, brown ones, development managers, and the head of development operations. And they say, security of applications is a critical part of my responsibilities. Well, the managers think, yeah, 80% of them said, yes, that's true. But only 27% of the developers thought so. They didn't think that security was part of their operation. Security considerations to be part of the software development lifecycle. Well, about half the developers thought so, although 85% of the development operations people thought so. Do they understand the threats? He says, I understand the latest threats to application security. Are they properly trained? Do they know that? Well, 64% of the developers thought so, but more of the head of the operations thought so. Yeah, head of operations had a rosier idea of their system than did the people who were actually doing it. This also comes out to this interesting security. Did they release code, or how often do they release code that they know to be insecure? In other words, when they push it out the door, do they know that it has bugs in it, security flaws? Well, they have the developers, the managers, the head of the operation, and you can see the developers think, about a quarter of the time they're good. And when they put it out, but 3/4 of the time, they go, yeah, it's got some problem. So what would that be? 73% of the, no, 73% of the time, they think there's probably something in there. Managers and the head of their operations are even less optimistic. They think that they combine all this, about 81% of the people think, yes, some of the time they're sending out insecure code. And some of them think about 1/5 of the time, 20%, they frequently send out code that they know has flaws. Now, of course, why do they do this? Well, that's because people have deadlines. They were supposed to, somebody way at the top establishes a release date for the software. And then the people who actually make it struggle mightily to get to that point. And sometimes they may have gotten through the planning, architecture, the coding, and then when it goes to testing, they didn't quite get to that step yet, but that'll come. We're just going to push it out the door because it needs to go. There was an app development event here in town. It was a couple of years ago. It was held and held out the A&T Farm or whatever it is now. But there was a fellow there from a company in town that develops apps. That's he has a business. There are lots of actually computer companies in town. But there was a small company that developed apps. And I was talking to him and asked him, well, what do they do for testing? Testing? They didn't do any testing. Their customers are telling them it doesn't work. They did no testing at all. Not just no security testing. They said, well, the developer should run the code to make sure that it works. But they didn't do any testing. So it's likely that they probably pushed things out the door that had security flaws in it. And then, I think I talked about, and then they asked, again, the developers, the managers, given time to learn. 2/3 of the management thought yes, but the people said, no, I have time, no. And then, interesting down here, learn from our mistakes to develop more secure applications. Only about 1/3 of the developers thought so. More than 2/3 of the management people thought so. And so this is a rather pessimistic report saying, well, yes, we know these are problems, but are we actually doing that? Well, not too much. And again, another problem is poorly documented requirements and assumptions. In the beginning, some people don't, even though they try to write secure code, they don't really have good documentation of what they're supposed to do. And so they run it along with APIs. They don't have necessarily, aren't necessarily secure. They often find this out by trial and error. They don't have a solid plan for secure testing. Again, another problem is internal documentation. How when people write different modules that will interconnect, how well defined is the interface. And sometimes one method will call another method, and he thinks he knows what the calling requirements are, but maybe he's not actually accurate. Maybe the day-to-day testing is not exactly what their calling method is expected, and it doesn't check. There's all sorts of a lack of security processes. Again, security is all not considered throughout the entire development life cycle, even though it's been learned over and over again that that's cost effective. Previously, computer security was not taught in computer science departments, but now at least our department talks about it quite a bit. How many of you are in the the secure software engineering track of our master's program? Anybody? You've got one? Nobody wants to be in that. Okay, actually, tracks have kind of gone to the wayside, but okay. And then there's relative security. It seems like it ought to work. Yes. And there's an interesting information about flaws. It's much more difficult, expensive to fix them once they're in the field. Also, if there are flaws in the brand, it tarnishes the brand image. If this company's software tends to have flaws, it makes it not look very good. And Microsoft also calculates that it costs $100,000 to patch everybody's software. So if they find a flaw in your Microsoft operating system, second Tuesday of the month, which is tomorrow, by the way, they send out fixes, and then each one of those costs $100,000. Because actually, when they create those fixes, they then have to test them, regression test them, do a whole bunch of testing on them, and on different machines, because Microsoft operating system runs on everybody's different machines. They run on desktops and laptops with a wide range of processors. You've got AMD processors, you've got Intel processors, and different types, different architectures, different brands, and they want to make sure it works in all of these. I went to Microsoft a couple of times, and they walked me through their testing area, and they have huge banks of different computers that they use for testing. In other words, they've got Dells, Lenovo's, and Acers, and every brand that they can think of there in a rack, and they use those to test their software. So when they want to see if it works, they want to test on all different architectures. And then sometimes they don't send it out. Once it gets out there in the field, other software-related things, putting it in places that are safe. Registry keys. And if you have files that you access, are those files protected against other people accessing them? Can people read and write those? And that, of course, makes the software less secure if people can access those. Registry keys, by the way, Microsoft Windows, I don't know about Mac, but probably somewhere, there is something they call the registry. It's a database of information that programmers use to look things up that contain information like who is the, what's the temporary file, where they're supposed to be located, what settings are being used by all sorts of software. They're all kept in the registry. And generally, you can look at them all. Okay, that's it for today. But don't run away yet. There's a couple more items I want to cover. Okay, again, we're on Unit 11. Go on Blackboard, look under Learning Unit 11. We had Unit 13. We moved 13 ahead, that's all. There are some reading assignments on Unit 11. There's nothing in the 2 textbooks for this class. We're not looking at anything there, but we are doing this, and it's short. Don't worry about it. Some of the reading material before, one of those lectures was like 90 pages, really long. This is short. And next week will be online only. Don't bother coming here to class, but Wednesday we'll be here. And tomorrow, the TA and I will be on Zoom, usual 725 Zoom, and we'll talk about projects 5 and 6. And again, we just talked about secure software development. We'll be talking about encryption on Wednesday. I assume most of you already know about encryption. I'm just going over it again, zoom through that stuff just to review it. Talk about some common security flaws next week. Okay, now I want your opinion on some things. I've been running the course pretty much as Dr. Yuan laid it out, using the projects that Dr. Yuan devised before I became involved in the course. She wrote all the projects, she and her TA. She made a bunch of slides. When I took this over, she told me, hey, don't worry, we got slides for all the classes. Well, she had a PowerPoint file for a week and it had 15 slides in it. I'd have to talk real slowly to spread 15 slides out. So I had to put a bunch of stuff in myself. So as you probably figured out, I took off all the pretty stuff on her slides. She has ferns and other things. I took those. I hope you don't mind. I did studies with students earlier. They want a plain, students generally voted for plain backgrounds, a white background, black lettering. And maybe you think otherwise, but that's what I used because that's what students told me they like the best. Anyway, we've got a couple weeks. The next week, we're just going to go through a variety of security problems that you may or may not know about. And we will talk about how those are addressed and what you can do to protect yourself against them, how those attacks work. I've taken out the ones we already covered. Dr. Yuan's slides had a lot of stuff on like SQL injection. I think we've beaten SQL injection to death, so we're not going to cover that anymore. But is there something you'd like? Have we missed something? Is there something when you signed up for software security testing, you thought you'd learn that it doesn't appear you're going to learn that I could put in there? No. Okay, I'll just keep making it up myself. And what kind of assignments would you like? Oh, okay, here's a tricky question. We have lots of opinions on this. The questions or the reason for the TA session tomorrow to discuss projects 5 and 6 are primarily environmental problems with the Ubuntu virtual machine, not necessarily problems with the assignment or the student's capability to do that. So you've seen the last of TuneStore. It ain't going to happen again. I'm going to not use Tune. There's only one more project anyway. We're not going to use TuneStore. I'm going to make up something new. TuneStore project was supposed to be on clickjacking, which we talked about next week, and of course, this is the project for next week. There's nothing due Sunday, although at the end of this week, I'll something will appear on Blackboard for the project for next week. It will be due on 21st, Sunday the 21st, which is the Sunday before Thanksgiving. Oh, and remember, the week of Thanksgiving, we have a class on Monday. There is no class on Wednesday. Wednesday is part of the Thanksgiving break. So I am planning on a clickjacking assignment that you do outside of the Ubuntu virtual machine. I think that's got to be easier. There's no Ubuntu issues. I think we'll just run it in Windows or on Mac OS, whatever you want to. And I'll point to a website and say, hey, make that do something, make that do this. And you can do that by clickjacking, by creating a web page that overlays it. The samples I did earlier last week, we talked about clickjacking. I'll make sure those are available on, well, I think they're in the slides, but I'll even put the HTML out there on Blackboard so you can access it. I think I'll put it out there, change the extension to like text. Otherwise, every time you touch it, it wants to run it. No, that's just let you download it, look at it, and then you can do something with it. And I'll make up some assignments, and it'll be relatively easy to grade because there'll be a goal. I want you to make something that we go out to look at this existing website. It'll probably be an existing commercial website, and you click here, you're going to send your cookies to some other site. Easy enough problem. And you can do it outside of, so therefore you shouldn't have environmental problems. It should be relatively straightforward.
And that will be project 7, right, Professor?
Yes, project 7, released at the end of this week, due Sunday, November 21st.
All right.
Okay. Anybody, is there something you'd like to see? Is there something you think, oh, I wish we did this in class that we haven't? No. I gave you the choice. Okay, well, then I'll make it up myself. All right, well, and that's it for today.
I have one more question, Professor.
Yes, sir.
Yeah, so for quiz 13, like we still cannot see the answer. So it was due on Sunday, right?
Yes, you can't see the answers to that yet?
Not yet. Nope.
Okay, let me go back and work on that. I'm sorry, I thought you could see the answers to that. It's never been as easy. I will do something tonight. Either I will tweak Blackboard until it forces it to give the answers, or I'll just make a document, put it out there with the questions and the answers, which should be relatively easy. Okay.
All right.
Okay.
Thank you very much.
Somehow. I'm sorry. Sometimes.
No, I'm saying thank you very much. Yeah.
Okay. I apologize. Sometimes Blackboard just doesn't behave as well as you'd like it to. Okay. That's it for today. Next time, we're going to talk about encryption. You already know about encryption. You can just fall asleep and not worry about it. Although, who knows? Maybe I'll think of something you hadn't thought of. Okay. See you then.
All right. Thank you very much.
And encryption, of course, does appear in the quiz for this week, which has already been posted on Blackboard.